IPsec has two modes, tunnel and transport. Let's start with tunnel mode. Tunnel mode is the default mode where the entire original IP packet is protected by IPsec. This means IPsec wraps the original packet, encrypts it, adds a new IP header, and sends it to the other side of the VPN tunnel. Technical keynote: IPsec tunnel mode is also known as link encryption and is commonly used for VPNs when using tunnel mode. Now, in tunnel mode, there are two types of headers, aka lanes, known as the ESP encapsulating security payload and the authentication header, AH. To explain these two header types, let's use an analogy of a delivery truck which needs to choose its lane. Firstly, we must understand an important concept. What is the original IP packet? Well, the original IP packet consists of three separate elements, being the data, the TCP, UDP, and the IP header, which are encapsulated together to form the IP packet. It is extremely important for both the exam and your general knowledge that you understand the formation of this original IP packet. What's even more important is that you understand the concept of encapsulation and decapsulation at the deep underlying technical level of the OSI model. I would highly recommend that you watch my previous video on the OSI 7-layer model if not already before continuing with the rest of this video and analogy. For your ease and convenience, I have linked that previous video in the top of the screen now. So, back to the video and the truck analogy. Let's start with the authentication header and how this practically protects the original IP packet by adding additional headers. The first being, you guessed it, the authentication header, AH. The job of the AH header is to protect the entire IP packet, but with a very important technical caveat. The AH header protects everything that does not change in transit, meaning the AH does not protect all the fields in the new IP header, which is the second additional header added in the IPsec AH tunnel mode, due to the sender not being able to predict how the new IP header will change as it transverses naturally across the networks. However, the job of the AH is to ensure the integrity of the rest of the packet stays intact. Moving on to the next lane, aka header, known as the encapsulating security payload, ESP, which is a bit more complex than the AH because it can provide authentication plus relay proofing and integrity checking. However, the key differentiating factor is that the ESP provides encryption of the payload data, after which the job of the ESP trailer is to provide authentication and integrity checks for the encrypted data and the IP header. The ESP header, however, is placed before the encrypted payload and contains information about the encryption algorithm and other security parameters. In other words, the ESP header and the ESP trailer are tag team partners that are then managed by the ESP auth trailer, which is appended after the ESP trailer to provide authentication and integrity checks for all these ESP components. And again, just like AH, a new IP header is then added to the overall packet. Important technical note: remember that a new IP header is always added in IPsec tunnel mode, but this is not the case in IP transport mode, which we will learn later in the video. So, to further illustrate the breakdown of these components within the IPsec tunnel mode, remember the structure of the original IP packet, aka the black boxes, which can go into two lanes, aka headers, either the authentication header or the ESP header. Only the ESP header provides encryption. Remember, E for encryption, E for ESP. And also, tunnel means link, aka link to link encryption. And ESP is the most commonly preferred header. So, to highlight in the authentication lane, here is the authentication header. And in the more complex ESP lane, here are the breakdowns of the ESP header components, starting with the ESP trailer, which is encrypted with the ESP header, which is then further encrypted with the ESP auth trailer. Now going back to the AH header, this provides integrity by protecting the data from tampering. However, remember the AH header does not provide encryption. That is the job of the ESP header, meaning the AH header won't stop people from seeing the data, but will stop data from being tampered, whereas the ESP header will protect data by encrypting the data payload, in addition to also providing authentication, aka tamper proofing. Let's move on to the next mode of IPsec, known as the transport mode, aka end-to-end encryption. IPsec transport mode is used for end-to-end communications, for example, communication between a client and a server, or between a workstation and a gateway. A good example would be an encrypted telnet or remote desktop session from a workstation to a server. To help illustrate IPsec transport mode, let's use the analogy of a plane approaching a landing where it can choose again from the two IP headers being the ESP and AH, in this analogy being the two landing lanes. Now, for the most part, these two header components remain largely the same as tunnel mode. However, there are a few nuances to be aware of. The most critical nuance to remember is that the original IP headers in transport mode remain intact, whereas in the tunnel mode, if you recall, the new IP headers were appended to the original IP header. So let's look at how the authentication header looks in transport mode. Well, firstly, we have the original IP packet, which is the data, the TCP UDP, and the IP header combined. Then appended is the authentication header. But here is the catch. The IP header is then the original IP header, which is reappended to the top of the packet, as opposed to a new IP header, which was the case in tunnel mode. Okay, so that's the authentication header. So what does the ESP header look like in transport mode? Well, similar to the authentication header, we have the original IP packet, but with some additional ESP header components, starting with the ESP trailer, which again alongside the ESP header, not to be confused with the auth header. So let's remove that and add the ESP header, which ironically can do the authentication anyway, but has the bonus of encryption. Again, the ESP header and the ESP trailer are then encapsulated within the ESP auth trailer. But remember that critical nuance, the original IP header remains intact at the top of the suitcase stack. Hey, that rhymes. Oh yeah. So the breakdown of the ESP header components are as follows. You have the original IP packet, which is encrypted and held between the ESP trailer and the ESP header, which is then encapsulated by the ESP auth trailer. And then the key critical nuance of transport mode, where the original IP header is just simply put at the top of the suitcase stack, rather than a new IP header, aka a new suitcase at the top. And for any fantastic viewers, hopefully subscribe to the channel, still watching, here are some bonus exam tips. Remember in transport mode that the IP header is exposed in both lanes of the ESP and AH headers. And I can simply not reiterate the importance of understanding the OSI 7-layer model, which is referred to in a previous video, linked earlier in this video. And to recap everything from this video, here is a nice on-screen display of the two IPsec modes being tunnel and transport. And finally, I hope this video has been useful and simplified the complicated process of IPsec. I really wanted to create this video as I often struggled to understand IPsec during my revision for the CISSP exam, and how I wished for a video like this where somebody just explained IPsec like I am a 2-year-old. So it would be super fantastic if you could leave a like or comment on this video, as well as subscribe if not already to the channel. to continue supporting its incredible growth. And of course, be sure to check out my other videos across my channel.